In this video, we're talking about the external division of the line in the given ratio. In the previous video, we looked at the internal division of the line in the given ratio. We looked at how to derive the formula, we looked at how to apply the formula, and also how to solve questions using the formula and a more direct approach. I'm going to be doing the same thing in this video, but this time around for external division. What does it mean when we are dividing a line externally? So let's say we're given a line AB, this line AB, AB, we're given line AB. And then we're told that this line AB is now extended to point A, this point here, point A. Initially, the line is AB long. But they now give us an extension, BA. And now we're being asked to find the coordinates of A. So it must mean that A is actually dividing line AB externally. What do we mean? That is, we must know the ratio, or if I'm giving the ratio rather, of this AE, I'm giving the ratio to be M. I'm giving the ratio of BE, we're giving the ratio here to be N. Then definitely we know that what will be remaining here will simply be M minus N. Okay, now that we've talked about this, the same thing we did in the last video where we used the concept of similar triangles. Now you can see that we have two triangles here, the big triangle, which is AEC, and then the small triangle, which is BEF. So we're going to look at these two triangles. If they are similar, then we can take the ratios of their side and equate it to M over N. What do I mean? And see at point A here, my coordinates, let's say my coordinates should be x1, y1. At point B, my coordinates should be x2, y2. And at point A, which is what I'm looking for, or which is the coordinates I'm looking for, let me call my coordinates x, y. Using the concept of similar triangles, then I must say AE over BE. AE is the longer side from this point to this point, which is AE, and BE is the shorter side, BE. If these two triangles are similar, then AE over BE must be equal to, again, the longer base side. I can say AC over shorter base, BF. Also, I can say this is equal to EC over, okay, what's shorter one? EF. And then lastly, I can say this is equal to N over N. So just like we did for the previous one, we're going to be taking any two. So I'll be taking AC over BF and equate it to M over N, just so I can find the coordinates of my X and Y. So let me quickly clean this part of the screen away, and then we can be on our merry way. All right, so AC, like we said, AC over BF, okay, must be equal to M over N. Now, what is our AC? If this point here, this point, the X value I'm having is X, and this point, the X value I'm having is X1, it must mean that in between, I will simply have X minus X1. Again, this point here is x2, this point here is tx, then in between we have x minus x2. Now that I've talked about this, let's combine them together. So AC will be equal to x minus x1, BF will be x minus x2, and then this will be equal to M over N. So what do we do? Cross multiply. Cross multiplying, we have N in the bracket of x minus x1 equal to M in the bracket of x minus x2. Okay, so multiplying this, what do we have? We have nx, okay, minus nx1 is equal to M times x, that's mx minus mx2. What are we looking for? The x coordinate system. So I can bring nx to this side and take mx to the other side. So here we'll be having mx2 minus nx1 will be equal to mx minus nx. So what do I do? Factorize the right hand side. So I would have, okay, so switching immediately, bringing this one to the other side. So it doesn't change the sign as much as I do the same for both expressions on either side. So factorizing this, what's common to both sides? I'm having x being common, and then this is m minus n. Okay, and this is equal to, again, what's common? Okay, so I can leave this one as it is. So here I have mx2 minus nx1. So everything divided by m minus n. Okay, I have not asked myself to divide. Okay, sorry about that. So lastly, divide both sides by m minus n. So also this one m minus n. And you see that our x here will be equal to mx2 minus nx1, everything divided by m minus n. Now that we've gotten the coordinates for the x value, so definitely we know that the coordinate for the y value should simply be y will be equal to my2 minus ny1 all over m minus n. We're going to look at how we can derive this expression. So how to derive this expression itself. So look at how to derive it for y coordinate system, and then we can now apply our questions. Okay, so let me quickly rub off the screen and just write this one at the bottom place. So work our way towards that. So my2 minus ny1, everything divided by m minus n. So trying to clear the screen now. So clearing the screen, we'll be having them. So okay, so that's perfect. All right, so quickly, so to get the y value, so which of the ratios we want to use? We're going to be using the EC over EF. Again, you see this is equal to M over N. So M over N. All right, so for the E value, so what's my EF value and what's my EC value? Again, the y value as at this point is y1. The y value as at this point is y. So in between must be y minus y1, and then this becomes y minus y2. Same approach we use for the x value. Okay, so for EC we'll be having y minus y1 divided by y minus y2. So this will be equal to m over n. Okay, what do we do? Cross multiply. Again, we have n y minus y1, okay, equal to n y minus y2. So this gives us ny minus ny1 equal to my minus my2. So again, take this n to this side, becomes my2 minus ny1, and bring ny to the other side. So this becomes my minus ny. So factorize the y. What do we have? So y is common, and then we're left with m minus n, and this will be equal to my2 minus ny1, Okay, so dividing both sides by m minus n, so we have it should be m minus n, and then again it should be m minus n. So you can see m minus n cancel m minus n, and then we're left with my2 minus ny1 all over n minus n. So lastly, since we've gotten our formula, we can now write the formula as an ordered pair. So we have it. So if we're given a line, and then we're asked to divide the line externally, given a particular ratio, then we can know that, okay, we can say the formula to use will simply be, so d of e now will be equal to, so that will be m of x2 minus n of x1, everything divided by m minus n, comma, and then m of y2 minus n of y1, so again, everything divided by m minus n. So this is the formula we want to use. So quickly, let's take a question and see how to divide or how to apply a formula to divide a line given a particular ratio externally. So we're given that P and Q divide the line AB with the coordinate of A being -1 and 2, and coordinate of B being 3 and 4 externally in the ratio 3 to 2. We have to find the coordinates. So we have to find the coordinates here. Now this is the same question we took in the last video when we're looking at the internal division. So just like what we did in the last video, I'm going to be looking at how to apply the formula to getting the coordinates of P and Q and also the direct approach. So the first thing we did in the last video was to do a sketch. So we just sketch what our line looked like. So we call this point A, or we're going to call this point A rather. So I'm going to be calling this point B, and then I'm calling this point P, Q. Now, at point A, the coordinates of point A are -1 and 2. Coordinate of point B are 3, 4, and then we're looking for P and Q, just like we said. Okay. Now, one other thing, the ratio. When you know from this point to this point, we're giving it to be 3, and from this point to this point, we're giving the ratio to be 2. So it must mean that from this point here to this point, the remaining ratio would be 1. So what I've just done is basic logic. If from A to this last point is 3, and from B to this point is 2, then definitely from A to B will simply be 3 minus 2, which is 1. All right, so using our formula, what's our formula? We know that d subscript A would be mx2 minus nx1 over m minus n, comma, and then we have my2 minus ny1 over m minus n also. Okay, so let's get that of x, so or that of p. So p now will be equal to, so what's my m? My m is 3, so 3 in the bracket of, what's my x2? So again, take b as your x2 and y2, so my x2 is 3, so 3 in the bracket of 3, minus, what's my n, which is 2, so 2 in the bracket of, what is my x1? My x1 is -1, so here I have -1 here, okay, divided by, so m minus n, so 3 minus 2, which is 1. Okay, so let me just write it as 3 minus 2, so you don't get confused. So 3 minus 2. All right, so 3 times 3, that's 9. Minus 2 times -1, that's +2. And then 3 minus 2, that's 1. And 9 plus 2, we have it as 11. So my P is equal to 11. So let me write it out there. And then let's find the value of Q using the same formula. And see how easy it is by just plugging and playing. All right, so for Q, so we say Q is equal to, again, write the same thing. What's my M? M is 3. What is Y2? So Y2 is 4. So 3 in the bracket of 4. Okay, minus, what is the N? N is 2. What is Y1? So Y1 is 2. So this is 2. And then divided by 3 minus 2, okay, which is still 1. So 3 times 4, that's 12. 2 times 2, that's 4. So we have -4 all over 1. And 12 minus 4, that gives us 8. So this is equal to 8. Again, let me write the value of Q here to be 8. All right, so now that we've done this using our formula, let's try and see the direct approach and see whether we arrive at the same answer. So otherwise, we've done something wrong. Okay, just like what we did in the previous example or in the previous video. So we're going to be taking the ratios of this side. What do I mean? So take the x for now. So I have -1, then negate this one. So I have -1 minus 3. So everything divided by, so here we have 3 minus p, and the ratio I'm going to be using. In the previous example or in the previous video, we used ratio 3 to 2. But this time around, this one we've separated here, we're using 1 to 2. So not 3 to 2. So as if we're doing the internal division now. So giving m and what's it called, giving and n. So here we'll be having 1 over 2. Okay, so without wasting much time, so -1 minus 3, that gives us -4. And 2 times -4, we have -8. Okay, -8 will be equal to 3 minus p. And 3 goes to this side, becomes -3, -8 is equal to -p. -3, -8, that gives us a total of -11 and -p. Okay, so multiply both sides by -1, we have p equal to 11. So which is what we had using the formula. So quickly, let's find our q, so we can call it a day on this video. Okay, so looking for q, we do the same thing, but this time around on the y-axis. So what do we do? So we just say 2 minus 4 divided by 4 minus q, and this will be equal to, again, 1 over 2. 2 minus 4, that gives us -2. Times 2 after we first multiply, okay, so equal to 4 minus q times 1 will give us 4 minus q. All right, so this is -4 equal, okay, so I can bring 4 to the other side again. So -4, okay, will be equal to -q, and q here, so -4, that's -8, so q will be equal to 8, which is what we had here. So far we've been able to look at the using the formula to calculate the external division of a given line, given its particular ratio. We've also been able to look at the direct approach to solving the external division of a given line, given a particular ratio. So this is all I have for this video. If this video has been helpful, do well to like it, share it to your classmates, your friends that are preparing for exams in maths, in further maths, and also you can also subscribe to the channel. If the video has not been helpful, just don't do anything. Thank you for watching.